In previous videos, we have mentioned and alluded to the concepts of building models. The easiest modeling technique to understand and learn is activity diagrams. We begin our discussion here by introducing you to activity diagrams. First, let's discuss the importance of models and building models during the development process. After we interview the users and determine what they need from the new system, we need to document those requirements so we don't forget them. How should we do this? Probably the most powerful technique we have is to building models. So what is model, or what is a model? A model is some representation of a portion of the real world that must be in the new system. Models are extremely powerful because they abstract out of the real world only those aspects that are important for the new system. Issues that are not important are dropped, and features that are important are precisely and accurately described. UML is the industry standard graphical modeling language for object-oriented development. One of the most important skills you'll learn in this course is how to build and utilize UML models. Why do we even build models? In this slide, we list 6 reasons why models are such as powerful tool in system development. First, we build a model. We come to understand the functions that we are modeling. It forces us to understand at a very detailed level to learn exactly how that function works. Second, it can remove points that are not important, focusing only on what is important for the system. It reduces the complexity into something that is more easily understood. Third, it helps us to remember all the details. Fourth and fifth, models are powerful or are a powerful communication tool, both to explain technical details to other team members and to explain aspects of the solution to the outside stakeholders. Finally, models are a simple way to document decisions that were made for future references. We will start on modeling skills by learning about activity diagrams. Activity diagrams are one of the easiest models to learn and to use both for system developers and for end users. First, let's define a workflow. A workflow is a sequence of steps that users goes to carry out a business transaction. In many of our examples, a workflow is usually a person interacting with a system. An example might be a clerk posting to a customer's account. The steps of that process are a workflow. An activity diagram then is an easy way to describe that sequence of steps. It is a useful technique to document a workflow. It is also a UML diagram. Although it's not specifically a UML diagram, it's not specifically an object-oriented model, but we still specify or describe this as a UML diagram. Let's look at the symbols that are used in activity diagrams. Remember, we are documenting a sequence of steps. A swim lane is a rectangular box that represents those activities done by one person or one entity. We put a heading on the swim lane, like what we see on the slide in here, to show who the person or the entity is doing those activities. And each activity is represented by an oval or a square with rounded corners, like you see in both of those activities in here. An activity is some action or one of the steps in the workflow. Activities are connected together with arrows. The arrow is used to transition from one activity to another or to the next one. And the direction of the flow is indicated by the arrow. To start and stop an entire sequence of steps, we often use a pseudo activity. These are simply solid black circles. Obviously, with any flow of activities, you sometimes have different paths that we can take. A path is nothing more than a set of connecting activities. Now, if we have an either-or condition, in other words, taking one path or the other path, then that is a decision point, as you can see on this slide here as well. There are two ways to demonstrate decision points, either with two or more outbound arrows from an activity, or by adding a decision diamond with outbound decision arrows on the corner. Remember, this is an or condition, taking one path or the other, but not both. On the other hand, sometimes we have situations that are multiple paths and both must be taken. We often call this concurrent path because both must be followed concurrently. This is an and condition. To demonstrate a concurrent path, we insert a synchronization bar. We insert one at the beginning of the concurrent path to indicate a split, and one at the end to show that they come back together or they join up again. Although it's not showing on this diagram, we also use synchronization bar to denote a loop. One bar to begin a loop and one bar to end that loop. Now, let's take a look at the workflow for the AutoMo order fulfillment process. This activity diagram demonstrates the component that we just discussed. In this case, we start in the warehouse swim lane. After the beginning pseudo activity, as you can see in the black circle in here, the first activity is to select order to process, which is done by someone in the warehouse. After an order has been selected, a transition flow goes to the order subsystem to locate the order in the database and then passes that information to the inventory subsystem, which starts a loop to loop through each item on the order list. We use a synchronization bar to indicate the looping process. They are beginning and ending synchronization bar in this swim lane, as you can see on the slide in here. Within the loop, the inventory subsystem finds the warehouse that has the item in stock. It will use a decision diamond to indicate if the item was found. If the stock was found, then somebody from the warehouse will pull that item, which will trigger the inventory database to decrement the stock count. Even if the stock was not found, the item will be ordered and inventory database will decrement the stock count as well. Then the loop ends. The order subsystem then sends the shipping details to the warehouse so it can prepare the shipment. The shipping company receives the information about the shipment and creates a tracking record in the database. That information is passed back to the warehouse. In this case, the path splits into two concurrent paths, as you can see in here. The warehouse sends the shipment to the shipping company, and the shipping company receives the package and takes control. Meanwhile, on the other path, The order subsystem updates the order information with information about the shipment. Both of these paths converge in the ending pseudo activity. Let's look at an activity diagram with several swim lanes, as you can see on this one. This activity diagram documents a workflow to process a new order in an engineering company. The workflow might be prepare an order for a production. So we're documenting the workflow for preparing an order for production. In this activity diagram, we have 5 swim lanes representing 5 different entities that participate in the workflow. The beginning or the start pseudo activity starts in the salesperson swim lane. The first activity is done by the salesperson in which he or she accepts the order. The order then passes over to the engineering swim lane. We noticed here that the transition is being accompanied by with a document or associated with a document called the order. This is an optional notation that is used from time to time to show the move of some type of document or articles. Engineering will make the specifications needed for the order. Make specifications itself is split with a synchronization bar. Remember, synchronization bar is to split a path into multiple concurrent paths. In this case, the activity buy materials is performed by the purchasing swim lane or department, and it's also concurrent with activity program computer and to be performed by the production department. These 2 paths then rejoin together before scheduling production with the scheduling department. Notice with synchronization bars that has concurrent path, both paths must start together and end together. If one ends before the other, it waits. One interesting thing to note about this activity diagram is that there is probably a use case for each activity. In other words, there is probably a more detailed workflow that goes with each activity in this diagram. In essence, this is a high-level workflow diagram that goes across multiple groups. Finally, let's just review the steps necessary to create an activity diagram. It's quite straightforward with just a few steps. First, identify all the participants in the workflow and make a swim lane for each one. Decide where the starting pseudo activities should go in which swim lane. It's usually the same place where the first activity is placed. Draw the ovals and the transitions based on the workflow steps. Add decision points for OR conditions, and then add synchronization bars for AND conditions and loops. This is a very simple process with few steps to create an activity diagram. Thanks for watching.